Okay, so we'll have a look at another question from the topic of electromagnetism. Here we're asked, when will a charged particle not experience a force due to a magnetic field? So in this case there's going to be two separate situations. The first situation will be if the particle has no velocity. So no velocity. So this is stationary. Stationary. Magnetic field in general will not affect a stationary particle. The second case is if the movement of the particle is in the direction of the field. So when movement is in direction of the field. We can demonstrate this quantitatively, and the way we're going to demonstrate this quantitatively is by using our magnetic field formula. So we know that the force due to a magnetic field is equal to the charge multiplied by the velocity multiplied by the field multiplied by the sine of theta, and the theta is the angle between the field vectors, field and the velocity vectors, field and velocity. So if the movement is in the direction of the field, theta is equal to 0, sine of 0 is 0. This reduces the force due to the magnetic field to 0. So in one situation, if you have no velocity, you're stationary, the v goes to 0. Second, if you have movement in the direction of the field, it also goes to 0. Now remember, this is assuming that this is a charged particle, right? And that the magnetic field is non-trivial. So Q has to be non-zero and B has to be non-zero. The only ways to send this equation to 0 are theta to be 0 or V to be 0. If we remove those conditions, you could say a particle with no charge will experience no force if Q is 0, or no field will exert no force. A field with a magnitude of 0 will exert no force. And of course that's not a field, really. A field with a magnitude of 0 is not really a magnetic field. But these are the two main situations under which a charged particle will not experience a force due to a magnetic field.